Okay, so today we are looking for a thermal related problems on CFD itself. So in this thermal problem, it involves a radiation and natural convection. So basically we have a cube structure which is having a length and breadth and height of 0.25 meters. So this cube has a 6 sides and at one face, so on this face, we are having a temperature of around 473 Kelvin, and this temperature is converged. The convection and radiation is happened. Uh, it the heat is transferred from this phase to all around the phases. Okay, so the ambient temperature, they said that is 293 Kelvin. Okay, also we have a gravity effect over here. So this is what our overall problem statement. So now we just try to solve this problem by using Ansys Fluent itself. So like always, we have that MHS file. So you know that the MHS files means which includes the geometry as well as the mesh data. Also, it has the named selection, everything. So we can directly enter into the CFD module and try to assign the viscosity and then energy equation. These things we can do in that process. And also we are interested to view the velocities and then temperature difference of the air. Okay, so inside we have a air structure. So now we're gonna do the analysis. We'll get started with the analysis. So first I'll open the Ansys workbench. So once it is get open, just drag and drop the Fluent flow. Once it is drag and drop, so I'm not going to create the geometry unless if you want to create the geometry, it's very easy to create, and you can create the named selections also. But I have the MHS file. So right click, so import mesh data file. So here I just import the radebox.mhs file, this one. So as soon as I click on OK, now I will have a green color tick. That means that file is imported in the CFD environment. So once it is get imported, just double tap on the setup. Make sure just enable the double precision. Probably it will increases your convergence. Okay, so once the model is get into okay, once the model is get imported in the CFD model, so here you notice that there is no inlet or outlet over here. So if you define any inlet or outlet, probably you may observe then arrow keys like inlet and outlet. So inlet in the red color and then outlet in the blue color. So we don't have anything like that thing. Okay. So the first thing what I'm going to do here is I just check the mesh whether we have any issues on meshing or not. So probably if it is having any issues, that will be shown over in the console. Then go with the gravity option. So I need a gravity over here. So the gravity is acted at the y-axis, that is also in negative minus 9.81. Okay. So once you define the gravity, go with the models. Since we are working with the thermal related things, you know that. So whenever if you want to define any temperature related things, you need to turn on the energy equation. So unless if you don't turn on this thing, probably you can't define the temperature related data in the CFD itself. Just double tap on the energy equation and enable the energy equation and click on OK. Fine. Then when we talk about the viscous condition, so here the air flows with a very minimum velocities. Obviously the flow is a laminar one, so we don't have any turbulence at all. The turbulences only happen if you have a higher velocities. Okay, so I'll choose the laminar and click on OK. So once it is defined, since our problem is related to the radiation, so that we need to enable the radiation. See, most of the factors are common for all the series, but in each and every exercise we learned a new thing, that is in our current problem statement. So the new thing is this radiation. So if suppose if you want to include a radiation effect in your model, how can I do that? So that is why we included this session on our series. Just double tap on the radiation. So since here the heat doesn't, the radiation has not happened to the ambient temperature to here. So I want to transfer the heat from one phase to another phases. So surface to surfaces. Okay. So I'll choose a type of surface to surface over here. So as soon as you chosen that thing, so I'm not disturb any other values over here. And you need to create a one factor and clustering files. Why it is needed means, because when you try to solve the problem at the end after the initialization, it generates a radiation factors. So it needs some place to save that factor. So that is why we need to create that thing. So just click on compute and write radiation. So it will create your project file location, or else if you want to choose your own location, you can choose that thing. So right now we already have a file over here. I'll just click on OK. So it asks me that whether you want to overwrite that file, or else if you want to create in a new location. So I want to overwrite this file, just click on OK. Note that this is very, very important, because if you don't if you don't create this file, probably your problem will not get initiated. Okay, because it needs some space to save that results. So that is why we just created over here. So once you created the thing, so just exit from that thing. So we have just created, turn on the energy equation, we define the whiskers and then radiation, then go with the materials. In materials option, right now in the fluid I have a air, and in solid I'll have an aluminum. Okay, what I'm gonna do here is I just change some of the properties of the air. Okay, so just double tap on that. So first I'll change the density to, right now it's set to constant. In my case, I need an incompressible ideal gas. Okay, I'll change that. See, if you don't want, if you are not interested to change these parameters, uh, we may not recommend that. Like, you can go with the default one, but I just changed that thing. Okay, so the CP should be 1021, and the thermal conductivity should be 0.0371, and the viscosity should be, I'll just slightly increase that value to 0.5. Okay, 48 e power minus 5. Okay, so I don't want to disturb the molecular weight, so I'll leave as it is. Just click on change and create and close. Now the properties of the air is get updated, and in the solid I want to create another material apart from the aluminum. See, it's basically made up of aluminum. All the surfaces is made up of aluminum. So inside that we have air. So we know that. So we have a two fluids at all. So I'll just double tap on the aluminum. Okay. So since I just assume that thing, like this four phases, like 1 and 2, so the opposite side 3 and 4 is made up of aluminum, and I have a convection and radiations on that four phases. But the top one and the bottom one phases, I don't want to assign any other, like no radiation and no convection has happened on that thing. So that is why, so instead of assigning that thing, I'll just select this phases like top phase and bottom phase. I'll made it as a insulation factor, like a insulation material. So probably you're well aware of that properties of the insulation. So the insulation means there is no conduction or convection or anything has happened. So the heat will not be transferred on that particular region. Okay. So how can I create an insulation material? Whether I can add from the Fluent database? No. Probably you don't have any insulation material from the Fluent database. So you have to create yourself. Okay. I'll create my insulation material. Okay. And insulation. So anything like, or else you can just yeah, give a random any factor, and the density should be, okay, so I'll change the density to like 50, and CP should be 800. And since it's a like insulation, it doesn't have any thermal conductivity factor, so I'll give as minimum as possible, that is 0.09. You can give any factor at all, it's up to you. So once it is done, just click on change and create. It says that you want to overwrite. No, I don't want to overwrite, because since I need the help of aluminum also, I'll say no. So if I say overwrite, this aluminum will be override with the material that is insulation. Okay. So, but right now I have a both materials like aluminum and then insulation material also. Good. Then I'll go with the cell zone condition. Just double tap on the cell zone condition. Just click on the fluid. Okay. By default, the fluid should be the air. So because we only have a one fluid, I'm not interested to change that thing. So still, if you won't have any confusion, just click over here and go with the edit. Just make sure the material is set to air or not. So once it is set, just click on apply and say close. And one more important thing is go with the operation condition. Okay. I want to change the operating density. Just enable the specified operating density. I'll make it as a 0. Okay. So once it is done, go with the boundary conditions. So now we need to define that here we have a higher temperature that's around 473 Kelvin, and all other phases are having a temperature of 293 Kelvin because the ambient temperature is 293 Kelvin. Okay, so we need to define that thing. For that, first I need to make sure uh, which should I make it as a hot end. Okay, maybe probably this one. So I'll try to choose this thing because when I try to choose this thing, nothing will be highlighted. Why? Because I don't yet enable the highlighted zones. So just enable this option. As soon as you click on that highlighted zones, so the from the boundary condition, whatever the named selection you choose, the region will be get highlighted. Okay. So this two things. Okay, this is top and this is bottom and this is side. Okay, this is what I need. Okay. So the W low X, I want to add a temperature of around 473 Kelvin. Okay. So just choose this thing and click on edit. Make sure the type should be wall because it's a wall. And go with thermal. And I'll change to temperature. Okay. So the temperature input, you know that thing like we are having a temperature of around 473.15 and the wall thickness should be 0.05. Okay. And make sure the material should be chosen as an aluminum. Good. Then the internal emissivity, because the radiation is involves in this problem, we have to define the emissivity. So the people who don't know about the emissivity, just try to Google emissivity. What is emissivity? You may get a lot and lot of information regarding that thing. Okay. So the internal emissivity should be it's around 0.95. I'll make it as a 0.95 and click on apply and say close. So now we just created the properties. I mean, we just updated the property for the W low X, that is this phase. And apart from that, I need to apply the properties for this one and this one and also this one. This three phases, 1, 2, and 3. So this 3 is made up of aluminum. Okay. What I will do here is, so this 3 has the same properties. So instead of assigning the properties for each and every named selection, I just choose only one thing like this one and click on edit. First, I'll define the properties for that phase. Go with thermals option. Choose mixed one because here we have a heat transfer and everything has happened. So that is why I'm choosing instead of go with the thermal, temperature, I'll go with mixed. Okay. So I'll give a factor of that is heat transfer coefficient should be 5 and the temperature should be the ambient temperature that is 293.15 and the emissivity, it's external emissivity not internal emissivity, so I'll say the external emissivity should be 0.75 and also this should be same. I just okay, I'm sorry, 273.15. Okay, it's 293. I'll just copy that thing and paste over here. And the wall thickness, you know that is 0.05. And go with radiation, we need to define the external, internal emissivity also, that is 0.75. Once you define all the values, just click on apply and say close. Now we just define w high x. So we need to copy that condition to this wall. I mean, not this wall, this one and this one. Okay. So I'll say choose this thing and say copy. So I want to copy this condition from to this one. Okay, I'm sorry. This from uh, high Z and low Z and click on apply. So all the conditions. Okay. So once it is get copied, click on close. Just make sure that thing like all the properties are correctly assigned or not. Just double tap on that. Go with thermal properties. See, automatically the properties will be get updated. And also make sure the material should be chosen as an aluminum. Close. And what about this phase? Yes, that's fine. Uh, okay, I'll just change the emissivity to 0.75 and click on apply. Close. Also for this thing also, go with radiation 0.75, click on apply and close. And also for this phase also. Okay, here it's applied. Good. So close. Now we just define the four phases like 1, 2, 3, and 4. And what about the top and bottom phases? So the top and bottom phases, it's an insulation material. I'll choose this thing like bottom phase, or else you can define this thing like double tap on that thing. So go with thermals, again mixed, but this time it has a heat transfer coefficient of 3 and having a temperature of 293.15, and just copy that value and paste over here. Then the external emissivity is 0.75. So the internal emissivity is 0.95, but we just defined as okay 0.05 wall thickness. I'll change to 0.75. Okay, it's not 75, it's 95. Click on apply and close. So I need to change this thing like it's not 0 point, it's 95. Click on apply. So here what, it's 0.75. So once it is done, I'll just copy the properties of X. Okay, so instead of copying that, I'll manually change that thing. It's not 75, it's 95. It doesn't make a huge difference, but it's okay to define the correct values. Oh, I'm sorry. Yes, it's get updated. Close. Once you defined everything, so no, so we are not defining everything. So we just define the three and top faces like this. So I want to copy this condition, go with copy like this one to the lower Y, that is bottom. Click on copy. Yes. But one thing we need to make over here is the material should be not aluminum, it should be insulation. And click on apply. And also for the lower one, double tap on it. Change the material type, should be aluminum. And other properties will be remaining same. Just make sure this should be 95. Here it's okay. Okay. Then everything is fine. So we define the boundary conditions at all. And we can move on to the next step, that is methods. Go with methods. I'll choose the scheme should be coupled and the pressure should be body forced weighted. Other than that, just make sure all the options are set to second order windups. And also the pseudo transition should be enabled. Then go to the bottom and say initialization. Just click on initialization. It says that you don't have inlet or outlet. Okay, now the initialization processes get completed and go with run calculation. So I'll give a iterations of 300 and click on calculate. Okay, now the calculation is get completed. So the next part is post processing. We will discuss about the post processing in our part 2 session. And, hope you like this video. We'll meet on our next video.